Welcome, Ichak Solution. We are continuing with our inequalities. So this is Modulus Inequalities part 3. So you have to watch for the previous lesson so that you see the progression that we have in the lessons here. Alright, so now we said in the previous lesson, when you're solving modulus inequality, you solve for the corresponding modulus equation to find the critical values. Then number 2, arrange the critical values using the inequality boundaries or region. Then number 3, you test for the boundaries to see the two region here. Alright, so let's go to this one. Solve the inequality modulus of 2x plus 3 greater than x plus 6 here. So you can see now here we only have the modulus sign on the left hand side here, while the right hand side doesn't have the modulus. So we are going to follow the same procedure here. Alright, so it's very simple. So let's go here. So we are going to find the critical values. So to find the critical values, we say you solve for the corresponding modulus equation. Alright, so the corresponding modulus equation is modulus of 2x plus 3 is equals to x plus 6. So this equation corresponds to this inequality here. So now we are solving for this one. So we are going to have 2x plus 3 is equals to plus or minus x plus what? Plus 6 here. Alright, so the next thing we are solving the two equations that we are going to produce here. So the first one is 2x plus 3 is equals to x plus 6 by taking a positive here. So we solve this one, we are going to have x is equals to 3. That's the value of x here. So now we are solving another equation. So another equation will be 2x plus 3 is equals to, so we are now taking a negative, so this minus will affect inside here, so we are going to have minus x, then minus times this one, we are going to have minus 6 here. So that we have, now we have 2x plus 3 is equals to minus x minus 6 here. So we can solve here, we can see 3x is equals to minus 9 here by solving this equation. Then you divide both sides by 3, so x is equals to minus 3. So now we have these critical values, so we are now going to arrange them on the table using inequality boundaries here. So it's going to be x less than minus 3, then we connect minus 3 less than x less than 3, then the last one is x greater than 3 here. Reminded that we said when you are starting here, you start with the smallest one, so it's x less than the smallest critical value, then you connect the next the smallest with the next critical value here. Then the last one will be x greater than the largest critical value here. Alright, so now we need to test here for the first region, the second region, and the third region to test whether which one is a true region, a false region, and a true region here. Alright, so we are going to be testing using this inequality that we have here. Alright, so the first region that we are going to test is for the region of x less than minus 3. So testing for x less than minus 3, we are taking any number that is less than minus 3. So we can take x equals to minus 4 and substitute it into this inequality here. So we are going to have 2 modulus of 2 times minus 4 here plus 3 greater than minus 4 plus 6 here. So we are going to have minus modulus of minus 5 greater than 2 here. So the absolute value of minus 5 becomes 5 here. So 5 is greater than 2. So it's true here. So this is a true statement which makes the region of x less than minus 3 to be true here. Alright, so now we are testing for the next region. So the next region is minus 3 less than x less than 1. So we need a number between minus 3 and 1 here that we are going to use to test. So we can use x is equals to 0. So by using x equals to 0, we are going to have a modulus of 2 times 0 plus 3 greater than 0 plus 6 here. So we are going to have modulus of 3 greater than 6. So the absolute value of 3 here is 3. So 3 greater than 6 is false. 3 is not greater than 6. So it's a false statement here. So which makes this region to be false. The middle region is now a false region. Alright, now we go to the next region. So the next region is for x greater than 3. So we are taking a number that is greater than 3 here, so you can use x equals to 4 here and place it into this inequality here. So you can see we are going to have modulus of 2 times 4 plus 3 greater than 4 plus 6 here. We are substituting in place of x. So now we are going to have 11 is greater than 10. Alright, so modulus of 11 greater than 10 will just give us 11 greater than 10. So you can see 11 is greater than 10, which is true. So which makes this region to be a true region here. So now we want to write our set of solutions. So you can see that there's this true region of x greater than 3, and there's also this region of x less than minus 3, which is also true. So the set of solutions is now x is less than minus 3, union x greater than 3 here. Alright, so now let's go to the next example. Alright, so our next example is solve the inequality modulus of 2x minus 3 less than x minus 5 here. Alright, so we are just following the same thing. We need to find the critical values. So to find the critical values, we are finding the corresponding modulus equation here. So we are going to have modulus of 2x minus 3 is equals to x minus 5 here. So we need to solve for this one. So this is going to be 2x minus 3 is equals to plus or minus x minus 5 here. Alright, so now we are going to have the first equation. So the first equation is 2x minus 3 is equals to x minus 5 by taking a positive. So we have 2x minus 3 is equals to x minus 5 here. So you can just solve for x here. So x is equals to minus 2 here. So for x equals minus 2. Then we take the next equation that we have. So the next equation is 2x minus 3 is equals to minus open brackets x minus 5. So we are now taking a minus here. So it's 2x minus 3 is equals to, so when you place a minus here, we're going to have minus x plus 5. So it's minus x plus 5 here. Alright, so now the next thing, we can solve for x. So it's now 3x is equals to 8. Then we divide by 3 both sides. So x is equals to 8 over 3 here. So now we are going with these two critical values on the table. So we are starting with the smallest critical value as we place them on the table here to test them. So we start with the smallest one. So the smallest is minus 2. So it's x less than minus 2. So it's x less than the smallest critical value. Then the next one is minus 2 less than x less than 8 over 3. We are connecting the smallest with the next one. Then the last one is x greater than 8 over 3. So we are taking now the greater critical value. So it's x greater than 8 over 3 here. So now we want to test these critical value, these regions that we have. Right, so we are testing them using these this inequality here. So first we are testing for x less than minus 2, this region here, the region which is x which is less than minus 2 here. So you can take any number which is less than minus 2. You can take x is equals to minus 3. So any number that is less than minus 2 is is applicable. We can use minus 4, minus 6, minus any number that is less than minus 2. So in this case, we just take minus 3 here. So we put minus 3. So you see, we are going to have modulus of 2 times minus 3 less than minus 3 minus 5 here. So we are going to have modulus of 9 less than minus 8. So which give us 9 is less than minus 8. So 9 is not less than minus 8. So this is a false statement. So which makes the region of x less than minus 2 to be a false region. Alright, so now we are testing the next region. So the next region is for minus 2 less than x less than 8 over 3. So we need a number between minus 2 to 8 over 3 here. So you can use x is equals to 0. So we are testing with x equals to 0 into our inequality here. So it's going to be 2 modulus of 2 times 0 minus 3 here less than 0 minus 5. So this will give us modulus of negative 3 less than minus 5. So the absolute value of minus 3 is 3. So 3 less than minus 5 is false. So which also makes this region to be a false region here. The region of minus 2 less than x less than 8 over 3 is now a false region. Alright, so now we are testing for the last region. We are testing for x greater than 8 over 3 using x equals to 4. Any number that is greater than 8 over 3 can be applied here. So you can use 6, you can use 10 here, any number. So in this case, we are using 4 here. So we take our 4. So you can see it's modulus of 2 times 4 minus 3 less than 4 minus 5 here. So this is going to give us modulus of 5 is less than minus 1. So the modulus of 5 is still 5, since it's absolute value of 5 here. So 5 is less than minus 1. So 5 is less than minus 1. It's a false statement here. So which also makes this region again of x greater than 8/3 to be false. So what it actually means, it means you see the first region is false, then the second region is also false, and the third region is also what? False. So it means there's no solution. There's no way which this function is less than this function of x minus 5. So in this case, we are saying there's no solution. All right. So we are going to be discussing these things as we move on. We are going to be doing some graphical ways so that you can see this function is not less than this function for all values of x here. So there's no solution here. Right. So let's say maybe we have true here. It means this function will be always less than this function for all values of what? Of x. All right. So this is what you need to understand here. Thank you for watching the lesson. See you in the next lesson.